Hello and welcome to 10.3, Solving Quadratic Equations Using the Quadratic Formula. Here we have two objectives. One is to use the quadratic formula to solve, and then to solve applications modeled by quadratic equations. Now, solving quadratic equations is not unfamiliar to us. We've seen this before. We've done, let me draw your attention to this part. Ax squared plus bx plus c. We've seen that, right? We've done BC method. And we use that method only when your a was 1. Then we have AC method. That was when a was not equal to 1. Right? We just saw square root property in the previous section. And this again has its own restriction. You can only use it if it's of the form x squared equals k. If you come back to our quadratic equation, you have the x term, right? But the square root property works if you do not have the x term. So all these are shortcuts to help us, okay? But we also have completing the square and other methods. We're not going to look at that. But we're just going to focus on quadratic formula. We love this because this works for all types of quadratic equations. Okay, so in other words, it doesn't matter what a, b, and c represent, right? They don't have to be whole numbers. They could be decimals, they could be fractions, they could be radicals, they could be anything, and we really can totally use this quadratic formula. Even for some problems where BC method or AC method really doesn't work, you can't find those two numbers, all those kind of situations will be handled nicely by quadratic formula. Because it does a lot for us, the formula looks more complex than usual. The formula itself is bulky, but it's doing a lot of work for us. So, it's a good thing that we have this formula. I will also post a video with the, or you can even find it yourself on YouTube, where you have songs and tunes set to help us memorize quadratic formula. One of the songs was set to Pop Goes the Weasel and so on. So it'll be very interesting for you to actually check that out. So here's the formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so now there are some important conditions. Okay, so if you look at the general formula, so the left side is your trinomial, and the right side must always be zero. Okay. If those conditions are clearly available, then you can go ahead and use the formula. If the right side is not equal to 0, say it's equal to 3 or something else, you can always handle that by subtracting 3 on both sides and making the right side 0. So just remember that if you had any other type, just see if it can be brought down to this version. Okay, our first problem is given here. So 2x squared plus 9x minus 5 equals 0. So before we jump into action, we have to scan this. So I'm saying, yes, this is a trinomial, meaning there are 3 terms of the form ax squared plus bx plus c, right? We've been seeing this all along when it came to polynomials. And we're looking at the right-hand side, must be 0. And that rule is also fulfilled, which means we can go right into applying the quadratic formula. To do the quadratic formula, we need to collect a, b, and c. So a is 2, b is 9, and c is negative 5. Let's write the formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. Now for this problem, you could probably use AC method, okay? But we're trying to show you that we can do the same problem even using quadratic formula, because quadratic formula works for every problem type of a quadratic equation. So I'll just say this was the quadratic formula. And I always recommend that we put parentheses around the terms where we're going to substitute. You'll really find that helpful and useful, because we will deal with negative substitutions too. I think even in this case, we have negative substitution because C is negative 5. All right, it's negative B, so B is 9. 9 here. A and C, so 2 and negative 5. And here it's A. Denominator is A, so we got a 2 there. All right, now it's just a regular arithmetic. We're just dealing with numbers. So 9 squared is 81 minus 4 times 2 times negative 5. So I see two minuses here, right? Minus 4 times the minus 5, so it becomes a plus. 4 times 2 is 8, 8 times 5, 14. 2 times 2 is 4. So now we have negative 9 plus or minus square root of 121 all over 4, which gives us negative 9 plus or minus 11 over 4. Now, if you look at this expression, what do? Do you do negative 9 plus 11 or do you do negative 9 minus 11? When we get to that point, when we have simplified everything else and we are left to deal with a plus or minus, that's a good time for us to split into two separate answers. Negative 9 plus 11 over 4, negative 9 minus 11 over 4. Okay. Again, remember that the plus or minus symbol is right before the 11. So 11 is the one that gets either a plus or a minus, and therefore that's the number that gets the split. All right, negative 9 plus 11 is 2 over 4. Negative 9 minus 11 is negative 20 over 4. Simplify these two, we get half and negative 5. And all along the variable was x. So x equals half and x equals negative 5. That is our answer. Of course, you need to perform the check by plugging in these two numbers in your original equation. Let's try this one. X squared minus 6x plus 5 equals 0. As always, scan your equation to see if it is quadratic and all the parts are. Yes, this is of the form ax squared plus bx plus c, and this is a 0. All good there. Let's collect a, b, and c. A is 1, b is negative 6, and c is 5. Write the formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right, I'm looking at a, b, and c. A is 1, which means we could use the BC method, right? And whenever possible, you want to use the easier method because that's quicker. But here the instruction is clearly to use quadratic formula, and so we're going to do that. Negative. And also to emphasize that even though BC method works quicker than quadratic formula, it's to prove that quadratic formula works for all types. And you will really appreciate it when you have a harder type, right? 2a. All right, so b is negative 6. Now look at the importance of putting those parentheses. The negative 6 is inserted in the parentheses with a negative already outside in the formula. And once again here also negative 6, 1 and 5 and 1. Okay. Negative times negative 6 is positive 6 plus or minus. Negative 6, the whole squared is negative 6 times negative 6, which is positive 36. Minus 4 times 1 times 5. So the minus does not have any other sign to combine with. So the minus remains. 4 times 5 is 20 all over 2. So that's 6 plus or minus square root of 16 over 2. And we need more room there. Okay, so we have 6 plus or minus square root of 16 is 4 all over 2. And here's a dilemma as to what to do with the 4. Do we add or do we subtract it? So we split the answer into two parts. So 6 plus 4 over 2, 6 minus 4 over 2. That gives us 6 plus 4 is 10 over 2. 6 minus 4 is 2 over 2. And that gives you 5 and 1. So again, the variable was x, so you say write x. If it was a y, then you write y. If it was t, you write t. Please match the variable correctly because you may get the answer correctly. But if you do not use the correct variable, you may be marked wrong. So just track all those things as well. perform check. So, excuse me. So if you're looking at the BC method, that would have given you these two numbers, right? You're looking for two numbers whose product is 5 and the sum is -6. So, you could use that same idea to get your answers too. All right. Excuse me. Solving applications of the quadratic formula. Okay. So you might be wondering, where do we even use this? And where do we use quadratic equations in the first place? And here's an example that kind of puts you in that situation. An architect is designing the entryway of a restaurant. She wants to put a triangular window above the doorway. Due to energy restrictions, the window can have an area of 120 square feet, and the architect wants the width to be 4 feet more than twice the height. Find the height and width of the window. It's a word problem, so steps 1 through 7 kick in. Okay, if you recall, we did that in chapter 3. We did that in chapter 5, and again we're looking at it here. So wherever you see word problems, steps 1 through 7, right? Read and reread the problem, draw a table or draw a diagram if necessary, step 1. Step 2 was to identify the variable. So, and then you translate the question into an equation, then you solve it, and then you check it, and then you interpret it, right? Those were the steps. We're going to remember to do that. All right, so now let's first draw the triangle. Could be anyhow, right? I'm just drawing a triangle because I'm thinking of this in the triangular window above the doorway, so maybe it looks something like this. And they say that the area, right? The area is the space inside. So I'm doing step 1 basically by drawing the diagram. The area is given to be 120 square feet. Okay. And then the architect wants the width. Okay, what does width mean here? Because width, if you recall, only relates to rectangles, right? Width and the length. Here they're talking about the width. So I think my diagram makes sense because talking about the width as the base here, right? Yeah. So let me write that out here. This is like the width because of the doorway, right? They talk about the doorway. They're trying to, and they're placing this above the doorway. So the width makes more sense to be the base here. And there's a mention about the height. The height is always from the vertex down to the base and should always form a 90-degree angle. So that's your height. Okay. All right, we have these things. Let's see how these are related. The width is to be 4 feet, excuse me, width is to be 4 feet more than twice the height. Okay, so let me just write here. This is step 1. Okay, we did the diagram. Step 2 is, where are we? We're asked to find the missing information. What is missing is height and width. Okay. So the width here is nothing but the base of our triangle. So in step 3, I'm going to call h as the height because it's very intuitive. Right? We have the formula and everything based on these specific letters. And I'll use b as the width. Although b is the base, the base here is the width. Okay. So step 3 is to assign variables. Step 4 is to translate this into an equation. So you have 2 things going on, okay? One is we're given that the area is 120 square feet. That's one piece of information. The other piece of information comes right from here. The width to be 4 feet more than twice the height. So width is, to be can be written as is 4 feet more than twice the height. Okay. All right, now we need to translate these into our equation. Okay. So let me write out here. A is the formula for area is half times base times height, right? So your area is given to be 120. Half times, do we know base? No, we don't know the base. Okay. Do we know the height? We don't know the height. So let me write it out there. Okay. And for that piece, we need the second piece to help us. Okay. So the width, we are calling the width as B. Is means equals 4 feet more, 4 feet more than, so it's plus, twice the height, 2 times the height. All right, so we got B in terms of H. So when I come back here, I get 120 equals half times B now is 4 plus 2H times H. Okay, that's in step 4. Step 5 is when we really solve this, because we can solve this for H. So 120 equals half times 4 plus 2H times H. Okay. So again, there are 2 ways to handle this. One is you could distribute this and then take care of it, or you could multiply both sides by 2. So I'm going to do that. I'm going to multiply both sides by 2 because that's the only denominator and I want to clear that. Okay. 2 times 120 is 240 equals 4 plus 2H times H. You know, the H can be in the front or at the back. It doesn't matter because we can still use the distributive property. So 240 is 4H plus 2H squared. Well, it's beginning to look like something. Remember, this is application related to quadratic equation. And right there, you see that the degree is 2. You know you're entering into a quadratic space because the degree here 2 tells you that you're expecting a quadratic equation. Okay. And now our job is to make sure that one side of the equation is going to be a complete 0. So you have the 240 and you want to get rid of the 240. So to get rid of it, you do minus 240 on both sides. Well, there is no like term on the right side, so this is basically a 0 here. 4H plus 2H squared minus 240. It doesn't combine with anything else. All right, now we can see that it's beginning to resemble our quadratic equation. We need to do a little cleanup. I would like to switch the spots, like the left side and the right side. And I want to rearrange them so that the highest power is the first term, right? Descending order of powers equals 0. Okay, this way it matches with what we've always seen. This is of the form ax squared plus bx plus c, and this is a 0. Now it's time for us to collect a, b, and c because we could right away use the quadratic formula. A is 2, b is 4, c is negative 240. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Let's plug them in. B is 4, 2, and negative 240. A is 2. Okay. Now it's time to compute this. All right, now we have negative 4 plus or minus square root of 16. There's a negative and negative, so we make it a plus. Okay, and then we need to multiply all of these. 4 times 2 times 240. 1920 all over 2 times 2 is 4. Okay. That will be negative 4 plus or minus square root of 1936 all over 4. And use your calculator. That gives you negative 4 plus or minus 44, because square root of 1936 is 44. Wow, that's a lot of force there. And then we have to split at this point. So negative 4 plus 44 over 4, negative 4 minus 44 over 4. All right, so this gives us 40 over 4. This gives negative 48 over 4. That's going to be a 10, negative 12. All right, so now we have, where are we? Oh, see, I actually made a mistake here. I wrote X. There is no X in the problem. They were calling it H. Sorry about it. But good that I caught it because we have to write out our answer with the correct variable. And so you come down here and say H is 10 or H is negative 12. Now come back and understand what this h actually represents. The h represents the height, right? Let's do that. Okay. So h is the height of the window. So again, let's go back to the question. What was it measured in? Feet, square feet. So it was measured in feet. So so we're saying height is either 10 feet or the height is negative 12 feet. Okay, how can feet be measured in negative, right? Distance, it's a length that cannot be measured in negative. So clearly, you see that out of the two answers, this has to be rejected because it's negative. So your height is 10 feet. Now using this, you can find the base or the width as they call it. Let me go back there. The width was b equals 4 plus 2h, right? b equals 4 plus 2h. So 4 plus 2 times 10. 4 plus 20, which is 24. Right? So you get h as 10 feet and b as 24 feet. This is still mathematical calculation. We are entering into step 6, where we're checking it. So when we want to check the area because they gave us area to be 120. So we want to do half times base, which is 24, times height, which is 10. We need to figure out if that is actually equal to 120. Okay? So do the simplification, the 2 and the 24, 12. Yes, we get 120 equals 120. That's looking good. Okay. Now we rejected the negative feet, and you want to provide a reasoning for that. Negative 12 feet for height. It's absurd. It's impossible, right? It's impossible as length cannot be measured in a negative quantity. That's the reason why we reject it, because there is a practical reason to go with it. And then one last step, we want to conclude. Okay. So let's say the height of the triangular window is 10 feet and the width is 24 feet. That helps us to conclude the answer with the number and the unit that goes with it. Okay. Please do it systematically. When it comes to word problems, it's a breeze when you do it systematically because it takes care of all these steps. And again, all these steps are provided to you. Go back to view the previous videos related to word problems. You can also go to the to our Canvas site to access the sheet that we used when we did those word problems with all the steps. Okay, let's look at the one last word problem. As you can see, it takes quite some time because of the quadratic formula. Right? Oops, this is scrolling off, sorry. Okay, Rene is setting up a holiday light display. He wants to make a tree in the shape of two right triangles as shown below, and has two 10-foot strings of lights to use for the sides. He will attach the lights to the top of a pole and two stakes on the ground. He wants the height of the pole to be the same as the distance from the base of the pole to each stake. How tall should the pole be? Okay, let's take it step by step. Okay, this is a holiday display and it's shown to us. Okay, and he's making this tree in the form of two right triangles, they say. That's a big clue for us. Two right triangles. The moment you see right triangles, keep Pythagorean theorem in the background. Okay, it might come in handy. Okay, and has two 10-foot strings of light to use for the sides. So that's already marked here 10. Okay, that means this also is 10. Okay. He wants the height of the pole. Okay, that's the height of the pole to be the same distance from the two stakes. These are the stakes, right? I'll call them stakes. stake. So he wants this distance, the distance of the stake from the height of the pole, wants this to be the same. We don't know what it is, so I'm going to call it x. But both must be x, right? Both must measure the same distance from the height of the pole. Okay. So they're saying, how tall should the pole be? Okay. Again, remember, steps always help us to break it down into manageable portions. So step 1 is already done for us. The diagram was given to us, but we added more details to it. And we got this. So they want us to find the height. To find the height, we'll need to find the x information as well. Let's get to that. Okay, step 2 is to write what is missing. How tall should the pole be? The tall here means the height. Okay. So I'll write the sentence as it is. How tall the pole should be. Step 3 was to assign a variable to this. Okay, so I will call this h, height of the pole. In fact, I want to go back to step 2 and say this is the same as finding height, finding the height. Okay. All right. So step 4 is to go ahead and try to build an equation that will help us to get this translated into math, right? So what do we do for that? So we do have two right triangles that are formed, right? So they are actually identical right triangles. So let me just zoom out one of them. So this is 10, right? This is the height. So I'm just zooming the right side of the right triangle. And this is x. Okay. Now we're going to use this to help build the equation. Okay. Oops. I cannot see the screen. Give me a moment here. Let me fix this. Okay. Okay, so in step 4, we have a crucial piece of information that's coming up from the sentence here. Okay. The height of the pole is to be the same as the distance from the base of the poles to each stake. How does that translate? Okay. Let me just write out here. Height of the pole same as distance from base to stake. Okay. We're only focusing on one side of the triangle, so it's true for both the stakes, but we're just focusing on the right side, so from the base to stake. Let's translate this piece of information that we just highlighted. Okay, height of the pole is h, same as distance from the base to stake. We called it x. Wow. So your height and your h and your x are supposed to be the same. So we come back here and we fix the diagram there and we say, well, h and x are the same. Now, if we use the Pythagorean theorem, that's where we do the solving. Okay. Pythagorean theorem requires the triangle to be a right triangle. It says c squared equals a squared plus b squared. And c is always your hypotenuse. In this case, it's 10. So 10 squared equals a and b could be any leg, right? So 8 squared plus x squared, that's what we had. We just established that h is the same as x, right? So because we're trying to find, so x and h are the same. So I'm going to replace the x by h squared. Okay? So 10 squared equals 8 squared plus 8 squared. Are they like terms to add? Yes, they are. Identical variable with identical power, and their coefficients are 1. So just trying to show you. That was 1 plus 1 with the 8 squared. So 10 squared is 2h squared. 10 squared is 100. 100 equals 2h squared. Are we going to use the quadratic formula for this? Well, you could use it, but remember, we always want to choose the easier method. So this is a method which is which could be used using the square root property. You do see the power as 2, you know it is quadratic equation. So we're going to use the square root property. According to that property, we need to get the square by itself. So I'm going to switch the places, okay? I'm going to write it as 2/8 squared equals 100. And then I want to divide the 2 on both sides. So you can see that I'm actually isolating the 8 squared to one side, okay? So 8 squared equals 50 is what we have. And then we could use the square root property, which is plus or minus square root of 50. Again, let me recall that it's square root property. We identified what to do there, but here we actually applied it. Okay, now we could do the simplification by splitting this up and finding the two numbers, right? That will go like 25 and 2. So we could do that. Let's do that. Plus or minus. Again, 25 square root of 25 times 2 square root of 25 times square root of 2. H is plus or minus 5 root 2, okay? But remember, it's a word problem, and this is good for checking purposes, mathematical purposes, but we have to come back and verify if this is to be used or not. So let's go back and see how it was measured. 10 foot, so it's measured in feet, right? So the pole is measured in feet. So this is basically your feet, okay? Now I'm going to work on step 6 to see if this is plus 5 root 2 and minus 5 root 2. Remember, these are feet. And feet is measured only in positive, so you eliminate that. So when you're checking it, you're checking to see if this is meaningful or not. It's not meaningful. And you're also checking to see if this number, this value itself is correct or not. So let's go over here. Okay. So the height and the base are basically the same, the length, right? So we need to see if the Pythagorean theorem works, right? So that's the only place where we can check. So c squared equals a squared plus b squared. So I'm keeping it like this to check for the correctness of the number. So this was 10 squared. We're trying to see if that is equal to 5 root 2 the whole squared plus another 5 root 2 the whole squared, because they were the same measure, right? X and H were the same. So that's 100. Is that equal to 5 root 2 times 5 root 2? So it's 5 root 2 times 5 root 2. Because it's squared, we multiply it twice. This is the reason why we learned about these things in the previous chapter, chapter 9. So that's going to be 25 times, because they have two square roots that are being multiplied, you can bring them both under the same radical. Whatever you do here, it works here too. 25. Times square root of 4. Square root of 4 is a 2. So 25 times 2 plus 25 times 2, which is 50 plus 50. You're almost there. That is equal to 100. Notice that your check really works well if you left it as a radical, right, with a square root. But nobody really understands if you go in the real world and say, I need 5 square root 2 feet of a pole, no one's going to understand that. So we're going to come back and interpret this, okay? So we'll say the height of the pole is 5 root 2 feet, which is approximately, and now you will use your calculator and then do 5 times square root of 2 and see that that gives you 7.07106 and so on, but you're going to just round it to 2 decimal places. Again, you'll have more instruction if you're doing it in a software, but for exam purposes, 2 decimal places is just right. Feet. Okay. So that will be the height of the pole that they'll have to purchase to set up this Christmas display. All right, so I hope that really was helpful. You're going to see problem types that may involve quadratic formula, problem types that may involve square root property in addition to the Pythagorean theorem. So you really want to draw your picture to realize from the clues of the problem which style to set it up. All right, I will see you in the next video.